Today we're going to start our lesson on surface area of prisms, pyramids, using nets. We're going to focus on prisms first today. So our first tab actually shows us what it means to have a net. It is a 3D figure that has been unfolded. So on the top you will see we have a rectangular prism and a triangular prism, and that is where we're focusing today. So when we look at a rectangular prism, it's named so because opposite sides are all rectangular. And then in a triangular prism, you'll notice that two sides are a triangle, and that's where the name comes from. So when you have opposite sides that are a shape that gives the figure its name, that's its base. So a rectangular prism has two rectangular faces at least, whereas a triangular prism has at least two rectangular faces. We're gonna go into actually calculating the area of our net. If you'll notice that we just have lots of shapes, so this is going to be very similar to our composite figures. The first one we're going to practice is a rectangular prism. So what we've done is we've taken a 3D figure and we've unfolded it. This should look very similar to one of the activities that we've done. On STAR, you will actually be given the numbers on the figure. This particular example does not do that, so we're going to write those in. So if we start with the base that's on the bottom, we see that it is a 6 meter by 5 meter rectangle. So we're going to write those numbers in on the base inside the net. So we're going to label one side 6, one side 5, and then we are going to see the tall side is 12, so we're going to label that 12. And then all the corresponding sides would then match. So our 5 will continue onto the top, and then if you'll see the 6, it goes on the left, we're going to put it on the right, and then on the next one that's similar, it's going to be 6 on the left and 6 on the right, and then you'll see that 6 carries out to the ends, and then our 12 is the long line, so we're going to go through and fill each long line with 12. Now that we have all sides labeled, we're going to find the area of the rectangles. And we know that the area of a rectangle is base times height. So our first rectangle is a base of 5 and a height of 12. So we're going to do 12 times 5 to find the area on that one. And 12 times 5 is 60, so that particular rectangle has the area of 60 meters squared. Then we have rectangles in the middle. We have the base of 12 and the height of 6, so we're going to do 12 times 6. And 12 times 6 is 72 meters squared. So we can fill that in and go to the next rectangle. So it's very similar to composite figures. This particular figure has the base of 5 and the height of 6. So we're going to do 5 times 6, which is 30. Now if you'll notice, the next rectangle is the same as the one on the left, so we don't have to recalculate. We see it's 6 times 12, and 6 times 12 is 72, so we can just fill it in. The next rectangle, we have 5 and 12, so we've done that before, so we can fill it in with 60. And the last one is a 5 by 6, so we can fill that one in as 30. Now that we found the area of each one of the pieces, we add them together just like composite figures. We're doing the math. Hold on, people. Okay. 10, 20 plus 12, 32. And that's meters squared because we just combined areas. Sorry about that. Now, if you don't like to add them in a long sequence like that, you can do 2 numbers at a time and then just keep adding to it. We just did it in one long sequence. All right, now the next one is a triangular prism. Same process. First thing we're gonna do is we're gonna fill in our numbers. So we see the triangle in the 3D figure has a base of 3 and a height of 4. So we're gonna label our sides. The small line is gonna be 3 and the tall line is gonna be 4. And we have 2 triangles, so we can just transfer those numbers over. Now, once it's folded up, we see that the sides of the rectangle on the bottom would also be 4 because that's the height of our triangle. So those would be 4 to match. And then the long side on that particular rectangle would be 10 from the picture, and we can take 10 and scroll that, or carry that on to all the lines. Now when we look at the picture, we see that that side that folds up on the top rectangle actually is going to match to the 5. So that one's going to have an area of, side of 5. Now we have all of our sides labeled, so we can identify we're going to use the rectangular formula and we're going to use the triangular formula. When we start at the top, we see we have a rectangle, so we're going to do base times height. So we do 5 times 10, and the area of that particular rectangle is going to be 50 meters squared. When we go to the next shape, we see we have a triangle. The triangular formula is area equals base times height divided by 2. Now this triangle does have 3 numbers. We have to remember our height is straight up and down, so the line that goes straight would be 4 and 3. So we're going to multiply 4 times 3 and divide by 2. So we now have 12 divided by 2, and that gives us 6 for that particular figure. Our middle rectangle, we're going to do base times height for our formula. So we have 10 times 3, and that gives us the value of 30. And we see that we have a triangle again. That same triangle is from the other side, so we can fill it in with 6. We don't have to recalculate. Our bottom rectangle, now if we look, it's 4 by 10. We have not done 4 by 10, so we do have to find that rectangle's area. We have base times height, so we're going to do 4 times 10, which is 40. Just like our previous figure, now that we have all the pieces found, we put them together to find the total. So we get a total of 132 meters squared.